Okay, example 8 is a lot like example 6 in that we're going to divide the complex numbers. They're in the wrong form for division. Again, the division process I've given you requires trigonometric form. They're currently in standard form. Again, going back to Algebra 2, we learned a technique for doing this problem already when it's in standard form. It looked like this. When it says quotient of one and the other, they want the top divided by the bottom. So -1 plus I divided by the square root of 3 minus I. And what we did in Algebra 2 when we saw this problem was we wanted to simplify by getting the I off the denominator. And the way we did that, we multiplied by the complex conjugate. So the top and the bottom both get multiplied by the square root of 3 plus I. Same first sign, opposite different second sign. And then we simply FOILed the top. -1 times the square root of 3 is negative the square root of 3. -1 times I is -1I. I times the square root of 3 is going to be plus the square root of 3I. And I times I makes plus I squared. All that goes over the square root of 3 times the square root of 3 is 3. Minus I times I makes minus I squared. The outer product and inner product both cancel. And you multiply by conjugates. That's why we want to do that. 3 is real. I squared is also -1, which is real. So everything on the bottom now is real. So that's how we did it in Algebra 2. That's how we tackled that situation. This is going to be -1. This is going to be +1. So we end up with reals of -1 minus the square root of 3. That's the real part on top. And plus the square root of 3 minus 1 times I. All over 4. And we separate them into two separate pieces like that, right? So again, back in Algebra 2, that's how we would have done it. If I were to get a calculator out to approximate the values of these, -1 minus the square root of 3 divided by 4 comes out to -0.6830. And if I do the square root of 3 minus 1, divide that by 4, that comes out to positive 0.1830. So just like that, we can get an answer in standard form. This is exactly right, this is approximately right, but typically if we don't get nice pretty answers, we're going to go with approximately right. And again, this would be a technique for getting an answer. This would work, and it represents a technique you've already learned in the past, so it's good to use as a checking tool because you use what you already know. I'm going to shrink that up, stick it over here. So if we go through the whole process again, though, if I want to divide in complex numbers with the technique I've given you in trigonometric form, here's the first complex number. So if I look at z sub 1 and I want to convert that into trigonometric form, step 1, r is going to be the square root of 1 plus 1. Alpha is going to be the inverse tangent of 1 over 1. And for theta, I'm going left and up. Left and up is the second quadrant. Second quadrant, as before, is 180 minus alpha, so 135 degrees. So the top vector, I'm dividing the square root of 2, CIS 135. For the bottom vector, z sub 2, once again, I want to find my magnitude first. R is going to equal the square root of square root of 3 squared, which is 3, plus 1 squared, which is 1. Square root of 4 is equal to 2. Alpha is equal to the inverse tangent of the second over the first absolute value, so 1 over the square root of 3. That's the same exact one we had in example 6, right? That was 30 degrees. And then this one I'm going right and down. That puts me in the fourth quadrant. In the fourth quadrant, theta is equal to 360 minus alpha, so 330 degrees. So 2 CIS 330 is the bottom. So again, job 1, if we're going to divide with this new technique, we want trigonometric form. Job 2 is to actually divide it out. So we're looking for something, CIS something. For that, I'm just going to get the square root of 2 over 2. That's exactly right. Okay? I can get an approximate value for that, which I will in a moment, because we're trying to match the approximate value. We want the answer in standard form. All right? If the angle here comes out to something friendly, maybe we get some exact numbers. We'll see what happens. I'm going to subtract these, and again, it's the top 135 minus the bottom 330. That ends up equaling 195 degrees, but it's negative because 330 is bigger. And as always, we don't want negative angles, right? So I'm going to do plus 360. That comes out to 165.
Mm-hmm.
Okay. 165 is not one of our special angles that we memorized the cosine and sine of, right? 150 we knew, 180 we knew, but not 165. So that just means I don't know what they are. So what I do is get a decimal approximation for square root of 2 over 2. Square root of 2 divided by 2 comes out to 0.7071. And then we got cosine of 165 plus I sine of 165. No reason anybody should know the cosine and sine of 165 off the top of their head. So cosine 165, sine 165. So cosine's negative 0.9659. That's the real part. And then 0.2588 is sine of 165. And that's got an I attached to it. So we get 0.7071 times negative 0.9659. And we get 0.7071 times 0.2588. That gets me negative 0.6830 plus 0.1830I, which is the same answer we got before, right? Again, the technique I want you to use is this technique here. So give me both answers in trig form, use the relationship for division in order to get the answer in trig form, and then convert over to standard form if requested. If the angles here are angles that you have specific knowledge of, 30 degrees, 45 degrees, 60 degrees, any kind of those angles, give me exact numbers here instead of decimals. If the angle here is not one of those special angles, then go ahead and give me approximate stuff.